Yes.
Good evening, everyone. I'm Shifali Keva, research scholar at IIT Madras, and this is our 8th session on the course maintenance and repair of concrete structure. So, in the 8th week, you might have studied about different protective coating for concrete infrastructure, and then you might have studied on the module waterproofing, where you might have studied different sources of water in concrete structures. What are the waterproofing principles? Different system of waterproofing, expansion joint, basement waterproofing, and roof waterproofing. So in this week, you might have studied about the different zones in near the sea of the concrete and what kind of attack would be there. Like in atmospheric zone, mostly it is a corrosion based attack. Same in high tide zone, tidal zone, and low tide. Different zones will have different type of attacks in it. And this thing you might have studied. Other thing, we go for the coating of concrete surfaces. So basic thing is the paint. What are the basic components of paints? Like additives, solvents, pigments, resins, and what are the different function of these components. After that, you might have studied about the different type of coating, like based on the structures and based on the application. What are the different type of coating? Like in this figure, this is anti-corrosion paint, which has been applied to the piers, and this is concrete mortar uh, paste coating. And then what based on the application of coating, what kind of coating we can use. Like if we are the airport runway, what type of coating has been used on this surface and why. Then the curbs and road surfaces, what kind of coating have been used. These are the different coating for floors. And then you might have studied about the different coating which can be applied in case of the fire resistance. So this is mainly about the coatings of concrete surface. So if anybody have doubt in this thing, please let me know. So the next module was on waterproofing. In waterproofing, the first thing you might have studied would be the dampness in building and what are the sources of water in a building. How can we identify that water is there? Mainly dampness is the first sign of water in concrete. Next is the what are the sources of these water? This water can be through gravity or because of surface tension or because of wind or air current, and other part is due to capillary section. So these four are the main causes of uh, dampness in the concrete surfaces. After that, you might have studied about the waterproofing system. So positive side waterproofing and negative side waterproofing. What is positive side waterproofing is outside the concrete wall we are applying the waterproofing, so to prevent the ingress of water into the concrete. And negative side to waterproofing is when we are applying our waterproofing inside the concrete surface, so that even if water is entering through the concrete, it is not disturbing the inside surface of the building or structure. So mainly negative side waterproofing we are applying on the basements where we can't go outside the concrete surface. And this type of waterproofing we can apply on the buildings which are on the surface or which whose outer side is applicable to us, like we can go there. Okay. After that, you might have studied different waterproofing membrane failure. What different type of failure can be there? Maybe there is overlapping of the membrane. There are defects in the membrane. Not proper wrapping is there. So different kind of membrane failure. After that, how what waterproofing methods we can apply. So here, first thing you might have studied are water stops. These are applied on the joints mainly. Some plastic material, different material will be used as the water stops. Next are the drainage waterproofing system. For drainage waterproofing system, we are applying weep holes, and for different type of buildings or structure, different type of weep holes are provided. Like for masonry, the mesh kind of weep hole is there. And for retaining wall, we have seen they are using pipes and some hollow pipes for as a weep hole. Next are the diversion waterproofing system. In diversion waterproofing system, what we are doing, we are diverting our water from the source to the different direction so that it doesn't deteriorate our concrete structure. So this is water diversion waterproofing system. In this also you might have studied different type of diversion waterproofing system based on the structures. Next is the sealant systems. So whenever there is a joint, we are applying sealant so that water does not seep through it. And there are two type of sealant systems. One is control joint, other is expansion joint. So uh, in control joint type of sealant system, we are using bond breaker tape, and in expansion joint, we are using backer rod, and elastomeric material will be same. So next is the in expansion joint. If we are using backer rod, it could be a circular long pipe kind of thing. So how it should be placed, how much pressure should be applied, and what are the different positioning which should be used for the backer system. It should not be too low, it should not be too high, and what are the disadvantages if it's not positioned in the correct position, and then what are the different failures of using this sealant system. Adhesion type and cohesion type failure. Cohesion type is in between the sealant, that is mainly due to if we are applying too much pressure or too low pressure, that kind of failure will be due to will cause cohesion failure. And if there is a failure between the substrate and the sealant material, if the sealant material is not properly placed, there can be a failure which is called as adhesion failure. So this is what mainly you might have studied for in this complete week. If anybody have doubt, please let me know. Okay, if no doubts are there, then we will go to the question and answer session for today. So the first question is, which of the following strategies will help to prevent moisture attack in concrete roofs? Providing drip edges at all the lintel bottoms, or pointing all the joints between the roof tiles, if any, and make them watertight, cleaning leaves and dirt from the roof, and or providing additional cement plaster on the exterior walls. For roofs, what can which strategy we can use to prevent moisture? Do you want to use the answer? You can type in chat box also. Pointing all the joints between the roof tiles and make them watertight. Okay. So if there is any joint between any roof tile, we have to make it watertight. Correct answer. Any other answer you think will be correct? See, providing additional cement plaster on the exterior wall won't help us to prevent the moisture attack on the roofs. So this will be the wrong answer. Then cleaning leaves and dirt from the roof. It can be the correct answer because if there are leaves and dirt on the rooftop, there are chances that the roots will expand and can cause cracking in the uh, roof slab, right? This option can also be correct. Next is the providing drip edges at all lintel bottom. So if we provide drip edges at the bottom of the lintel, what will happen? So providing drip edges at all the lintel, are, if this is our lintel and we are providing drip edges at the bottom of this lintel, it will uh, take away the water, right? But will it help in taking away the water from the roofs? No, na, the lintel, if lintel wall is quite a little bit below than the roof area. So even if we are providing drip edges at the lintel bottom, it will help us to, it won't help us to take away the moisture from the roof. So it won't be a correct answer. So the correct answer are B and C. Okay. Next question. Which of the following coating is not recommended for concrete or plaster surface? You might have studied about different coating in the lectures. Epoxy coating, zinc coating, chlorinated rubber coating, or alkyd coating. Which type of coating are not recommended for concrete surfaces? So, in when we go for the concrete surface coating, we have to make sure that our coating is not reacting with the concrete. If it's reacting with the concrete, with time, there are chances of shrinkage in concrete. So, if our coating doesn't have a good adhesion to the concrete surface, the coating will be removed. So, epoxy coating, we all know it won't react with anything. Zinc coating, even if it won't react with the concrete, but it will penetrate through the concrete. Zinc coating we are mostly using for concrete as a protective method, as a repair method. Next is the chlorinated rubber coating. So this coating also will not, sorry, this coating will also not react with the concrete surface, whereas alkyd coating, it is a type of chemical. It will These paint will react with the concrete surface. So whenever there is any shrinkage or any kind of defect in the concrete, this type of coating will curl up or will detach from the concrete surface. So therefore, we will say alkyd coating cannot be recommended for concrete or plaster surfaces. Okay. Okay, next question. Match the following. So we have read about two type of waterproofing system, positive and negative side waterproofing system. So these are the different cases. What do you think? Which type of coating should be applied on system? Swimming pool with the waterproofing membrane on the inner surface of the pool. So what type of waterproofing system is this? Positive or negative? A or B? You want to guess? It is a positive side waterproofing. Even it is if it is in the inner surface of the pool, why we are saying it is a positive side waterproofing system? Because we are telling positive side when coating is applied between concrete surface and the water layer. So inside of the swimming pool, this is a surface between concrete and water. So that's why we will say swimming pool, inside of swimming pool surface, it will be a positive side waterproofing system. Next is a bathroom wall with interior surface tile waterproofing paint. So again, it will be a positive side waterproofing system because in bathrooms we have water inside the bathroom itself. So if we are applying waterproofing paint on the interior wall, then it will be a positive side waterproofing system. Same reason as the swimming pool. Next is the terrace garden with plastic sheet between soil and roof. So in this case, again, it will be a positive side waterproofing system. How? If this is the terrace roof, then we have soil above it. So moisture will come from this side, like our soil will be hydrated. And if we are providing coating on the roof in between moisture from the soil and concrete of the roof, then again it will be a positive side waterproofing system. Okay. Next is the basement wall with interior surface having waterproofing paint. So this will be a negative side waterproofing system. How? It is a basement wall and we are providing coating inside the basement wall and our water will be outside because of soil, right? This outside of wall is soil, but we are providing our coating inside of the wall. So coating is provided after concrete, not in between concrete and water. So it will be a negative side waterproofing system. Last is the coating or lining on the inner surface of an underground metro line. So same, it will be a negative side waterproofing system when we are providing lining in the inner surface of any wall or any metro line or something, anything, and the soil is outside that concrete surface. The lining, the waterproofing is provided after soil, then concrete, then waterproofing, then it will be a negative side waterproofing. So answer is B. For 1, 2, 3, it is A, and for 4 and 5, it is B, negative side waterproofing system. Is this question clear to everyone? If you have any doubt in any point, please tell me. Am I audible to you guys?
Yes, ma'am.
Okay.
You told like the fourth one is negative or positive, ma'am. Fourth one,
Fourth
the
is
basement.
negative. See, in basement, we have, see, imagine this is a soil, then concrete, and we are providing waterproofing paint on the inside of the concrete. Means it's not between concrete and moisture, so that's why it will be a negative side waterproofing. Okay.
Okay, ma'am.
Next question. Typically, which among the following two waterproofing systems will help to prevent the hydrostatic pressure rising in the case of concrete retaining wall? Drainboards or forced gravel behind the walls, horizontal water stops, horizontal weep holes, or polyurethane coating. In the retaining wall, you might have seen that we are usually providing sorry, some drain boards. If we are providing drain boards behind the retaining wall or forced gravels, what will happen? The water won't penetrate through the wall. So first option is correct. If we are providing water stops were like in between expansion joint, we are providing these type of water stops. If we are providing water stops, it won't prevent the hydrostatic pressure which is rising in the retaining wall. So this option is wrong. Next is the horizontal weep hole. So in retaining wall, we are usually providing this hollow circular pipe kind of weep holes so that the pressure is decreased and water easily seep through the retaining wall. So this option is also correct. Next is the polyurethane coating. So what coating is doing? Coating is preventing water. Coating will prevent water to seep through the concrete, but it will create pressure on the backside of the retaining wall. So this option is also wrong. So in case of retaining wall, what are the best option? Either we will provide the drain boards. What drain boards are actually doing is, if this is the complete drain board or wall, the water will go, and here at the bottom of the drain board there will be some hollow pipe kind of thing, like a U-shaped pipe or something. So water will collect in that and it will go through and go through it and move outside. So it won't create a pressure on the retaining. So based on this, A and C are the correct option. Okay. Next question. Sulfate present in seawater can be characterized by, if there are sulfates in the seawater, based on from our if we see the concrete surface, how can we identify that there are sulfates present in the seawater? It will cause erosion of concrete. It will cause pitting corrosion. It will cause longitudinal crack in concrete, or there will be a growth of microorganism on the concrete. From the visual inspection, how can you identify that there are sulfate present in the seawater? See all the options. If there is a growth of microorganism on the concrete, why it can be? It can be due in the near the sea water, but it won't be due to the sulfates. It's mostly because of the wet and dry condition of the seawater. It have nothing to do with the sulfates. Next is the longitudinal crack in concrete. So longitudinal crack in concrete means along the rebar surface. If we have that kind of crack, then it is a corrosion based thing, not the sulfate based thing. Next is the pitting corrosion. We know pitting corrosion is mainly due to chlorides. Last option is the erosion of concrete. So if there are sulfate present in the seawater, what it will cause? It will cause the external sulfate attack to the concrete and will cause the erosion of the concrete, mainly due to abrasion and abrasion and cavitation. Okay. So if you see any erosion of concrete, mostly at the surface of the concrete which is in contact with the water, you will see this part will be eroded like this. If you see this kind of damage, it can be due to the sulfate present in the water. Okay. Next question. In an expansion joint in a building, the depth of sealant applied is more than twice the joint width. Choose the most relevant system. Mona, if there is an expansion joint, we are applying backer rod, cylindrical backer rod, and above that, some expansion material. This material we are providing. So if this depth is twice the joint width, this is the width. If it is more than if it is twice the width, then what kind of cause can be there? It can cause cohesive failure, adhesive failure, adhesion will not experience sealant will not experience adhesion failure at all, or it will fail due to compression relaxation and then buckling. See, this is the case. If this depth is twice the width of our uh, joint, then what will happen? It will cause some uh, pressure onto the concrete surfaces. If pressure is applied, then what happens? Uh, this material will fail at this point. Our sealant will fail at this point, and it will cause adhesion failure. So in case if our depth is twice the width, the type of failure will be adhesion failure. In other case, if our depth is very low, then what kind of failure will be cohesion failure, because too much pressure will be applied on this material and there will be crack here. So it will cause cohesion failure. Okay. Answer is B. The sealant failed due to adhesion failure. Any doubt till now? Next question. Which of the following is least important to consider while selecting backer rods? So these are the backer rods. It's a cylindrical pipe kind of thing. It is made of, mostly it is foam based. So what are the least important thing to be considered while selecting a backer rod? Width of joint, probability of moisture attack before the sealant is applied, type of cells in the backer rod, or density of the backer rod. See, as we have seen in the last question, width of joint is very important when we are selecting a backer rod. It should not be applied at a depth more than the width. If it is applied, then it will cause adhesion failure. If it is applied at the lesser depth, then it will cause adhesion failure, cohesion failure. So it is an important thing to be considered. Next is the probability of moisture attack before the sealant is applied. That is the most important thing we consider, because we are applying these backer rods based on that thing only for waterproofing. So it is also important. Next is the type of cells in the backer rod. So as I have told you, this backer rod will be mostly made of the form based. So if the form have too many, what is the microstructure of this form? It will affect the property of the backer, so it is also important. Next is the density of backer. So density of backer have no doesn't have that much role when we are selecting the backer. So answer will be D. Okay. Next question. The period of time after mixing that the material provides good application characteristic is called. The answer is working pot life. So after mixing, the time till which the material is providing good application characteristic, this time where we have where our concrete or any material is in still in liquid state, that time of life is called as working pot life. As in concrete system we are saying a setting time, so that will be a working pot life, the general term for these. Next question is, conditions that influence the coating characteristic include air temperature, substrate temperature, relative humidity, and or wind velocity. Based on our air temperature, we are telling what kind of coating we should use. We are telling if our air, we have too high temperature, we won't apply epoxy coating because there are chances of it to melt down. So air temperature will matter. Next is the substrate temperature. Same way, substrate temperature will also be affecting our coating because sometime if our substrate temperature is very high or very low, the adhesion between the coating and the substrate won't be a proper. So substrate temperature is also important. Relative humidity too. If our humidity is very high, we have adhesion issues between the substrate and the coating. Last is the wind velocity. So do you think wind velocity will have any effect on coating characteristic? So wind velocity also affect our coating characteristics. How? If we have to apply that powder kind of coating, powder coating we have to apply through spray, and our wind is flowing in the opposite direction. So it would be very difficult for us to apply that kind of coating. So wind velocity will also affect our coating characteristics as well as our application of coating. So answer will be all of the above, right? Next question is match the following different method of waterproofing and what are the water movement bar. If we are providing cap flashing, drip edges, sloping, or water stop, how they are preventing in which type of application these type of waterproofing method should be applied. Yes, these are the different type of waterproofing. This is a sloping type of waterproofing. This is a drip edge. We are providing a small cut onto the bottom of our wall, lintel, and this is cap flashing, and this is a water stop. So, what do you think? Which method is you? Which type of waterproofing will be helpful in case of capillary suction? First is the cap flashing. So, from the picture, you can see the cap flashing will be provided in case of winds, right? It can be seen clearly from the figure itself. In case of winds, we are providing cap flashing so that moisture does not enter through our wall. Next is drip edges. These are the drip edges at the bottom, at the corner of our wall. We are providing a small gap so that our water, it will fall down here itself. It won't go into the uh, at the connection. So drip edge can be provided where from the figure we can see it is the surface tension. Because of surface tension only, our water movement is at the bottom also, our water movement is like this. So to prevent the anything due to surface tension, we are providing drip edges. Next is the sloping. This type of sloping we are providing because of sloping here and here we are providing. That is mainly due to prevent seepage due to gravity. So in gravity, water is falling from the top and going into the surface due to the gravitational force. So if we are providing sloping here, water will not enter at the edges and will go through. So sloping is provided in case of gravity. And last is the water stop. So water stop we are providing here. Mainly it is due to prevent due to capillary suction. So water entering through the bottom, that is a capillary section. So to prevent this water from entering at the bottom, we are providing water stop. The answer. I think all type of waterproofing is clear to you guys and why we are providing it. Next question then. What are the properties to be considered to select a waterproofing chemical to use in exterior surface? If we have to use a waterproofing on the exterior wall or anything, which main things we have to consider before selecting it? It should have resistance against chemical attack. It should have puncture resistance. Puncture resistance means impact resistance against impact force. It should have resistance against UV radiations, or it should be flexible. So if we are providing our waterproofing in the exterior surface, it should have resistance against chemical attack, correct? It should have puncture resistance. So exterior wall, exterior surface only will have more chances of puncture or impact. So it should have a puncture resistance, resistance against UV radiation because our exterior surface is completely exposed to the uh, environment, and it should be flexible because there are chances due to change in temperature or something uh, our concrete surface can go through shrinkage or expansion, so our waterproofing chemical should be flexible enough. So answer will be all of the above. All are the correct answers, right? Okay. So this is a theoretical based question. What is the reason of cracking in the given figure? So there are pipes, a concrete beam, and some vegetation. What do you think are the reasons or can be the reason of these type of crack? What do you want to guess the answer? See, first thing you can see from the figure itself that this pipe is corroded from this point. So if corrosion is there, expansion will be there and it will cause cracks. So first is the this corrosion of pipe will cause the cracking due to water leakage. Okay. Yeah. So due to water leakage, what is happening in this case? Water is leaking. Because of that, there is some vegetation. Uh, Vegetation is there over the our concrete beam, and these we know vegetation will cause the roots will cause expansion and cause the cracking. So main reason is water only, water leakage. Water leakage is only causing vegetation as well as corrosion. So you are right, corrosion of pipe and the vegetation growth. And reason for both of these things is due to the water leakage from the pipes. So this is the last question for today. For roof waterproofing, person A suggests to go with a brick bat cover, whereas person B suggests a thin layer of effective waterproofing chemical. According to you, what is the correct, what would be the correct procedure for waterproofing? You guys can have a mixed opinion on this. If you want, you can type in the chat box. What do you think should be the correct waterproofing technique? Using the brickbat cover or using a waterproofing chemical. So this was an open-end question for discussion. Uh, so what is a brickbat cover type of waterproofing? In this waterproofing, what we are doing, we are providing a mod. On the roof, we are providing our mortar mix, and above that, we are keeping our bricks. So this is a brick bed coba waterproofing. And in the next is the thin layer of effective waterproofing chemical. Very nice. Next is the we are providing simple thin layer of chemical. So in case of expansion or in case of any shrinkage or expansion, what will happen in this case? This bricks will the bricks are more stiffer, right? So bricks will have cracks in between, and there are chances that water will penetrate through these cracks. Okay, so although this method has been is applied in many rural areas still, but if we have to go for a good waterproofing system, we will choose the chemical waterproofing chemical, a simple coating of waterproofing chemical onto the roof, so that the properties of waterproofing coating we have already seen in the previous question, that it should be flexible also, it should be resistant to UV. So all of these properties can be possible in a waterproofing chemical. You can synthesize that type of chemicals, but if we are using brick bed coba, there are chances that it won't be helpful in a long term because of the cracking in the bricks. So in this case, what we'll choose, you will think that waterproofing chemical is a more effective method, as you guys have already guessed. So that's all for today's session. If you guys have any doubt, please let me know. Since you guys have, you don't have any doubts, then we will close the class for today. Thank you, everyone.